Good afternoon, everyone. So welcome to my YouTube channel, Maths Akram. So today we are going to see 24th lecture on Riemann integration. In this lecture, we prove the integration by parts formula. Okay. So integration by parts. Integration by parts. Let f, g are Riemann integrable over AB. Okay. And fx is equal to capital Fx is equal to a plus a to x fx dx. Okay. Gx is equal to b plus a to x gx dx. Okay. Where a and b are constant. Then integral a to b capital Fx small gx dx is equal to capital Fx gx a to b limit minus a to b capital Gx small fx dx. If you see that this is integration by parts, okay, we will prove this result. Okay, how we will prove this result? Let's see. Proof. Okay. So for any partition P is equal to a x naught x1 x2 up to xn is equal to d of closed interval AB, we have what is capital Fx into Gx limit a to b. What is the meaning of this? This is nothing but Fb Gb minus Fk capital Ga. Okay. Now I can write this as summation I goes to 1 to n. Okay. Fxi Gxi minus Fxi minus 1 Gxi minus 1. Okay. Now I can add and subtract. So I can add and subtract. I goes to 1 to n. Fxi Gxi. Okay. Minus Gxi into Fxi minus 1. I can add and subtract. Okay. minus f x I minus 1 g x I minus 1. Okay. Now we can write this like this. We can write this like this. I goes to 1 to n gxi, okay, fxi minus fxi minus 1 plus summation I goes to 1 to n fxi minus 1 gx minus gxi minus 1. Okay. So finally what we got actually? We got this implies capital Fx gx limit into b is equal to summation I goes to 1 to n gx fxi. So this is gxi. So gxi minus fxi minus 1 plus summation I goes to 1 to n. Okay. fxi minus 1 gxi minus gxi minus 1. Okay. This is equation number 1. Let's see. This is equation number 1. Okay. So put mi is equal to supremum of fx x belongs to closed interval xi minus 1 to xi. Okay. And what is small mi is equal to supremum of fx, infimum of fx x belongs to xi minus 1 to fi. Okay. Capital Mi dash, what is this? This is supremum of gx. X belongs to xi minus 1 to fi. And small mi dash, what is this? Infimum of gx. X belongs to xi minus 1 to xi. Okay. Also put delta fi is equal to capital Mi minus small mi, and delta gi is equal to capital Mi dash minus small mi dash. Okay. We know that capital Mi minus small mi is nothing but supremum of fx minus fy, and xy belongs to interval xi minus 1 to xi. Okay. Okay. And similarly, mi dash minus small mi dash will be equal to supremum of gx minus gy, xy belongs to xi minus 1 to xi. Okay. xi minus 1 to xi. Okay. xi minus 1 to xi. So that, but this is equal to, but this is equal to, what is this? This is delta fi and this is delta gi. Okay. So this is so that, now what will be happen? So that fx minus fxi, which will be less than equal to delta fi. Okay. Because delta phi is supremum of xy, absolute of fx minus fy. Okay. And gx minus 1 is less than equal to delta gi. But from here what we got? We got fxi minus delta fi is less than equal to fx less than equal to fxi plus delta fi. Okay. And from here what we got? Gxi minus 1 minus delta gi less than equal to gx, and that is less than gxi minus 1 plus delta gi. Okay. So let's say this equation number 2. Okay. Okay. No. So do not say equation number 2. We will say later. Okay. Now from here what we will get? From this what we get? Because this is constant and this is also constant. Fx lies in between this. So this implies fxi minus delta fi delta xi is less than equal to xi minus 1 to xi, fx dx is less than equal to fx I plus delta Fi delta Xi. Okay. And what we are from here, what we will get? From here, we will get Gxi minus 1 minus delta Gi less than equal to A to B. Sorry. Xi minus 1 to Xi. Gx will become here. Gx dx less than equal to Gxi minus 1 plus delta Gi delta X. Okay. Now, this is fixed value and this is also fixed value and this is common here and this integral lies in between this. Similarly, same thing here, this is fixed. Okay, this is also fixed. This is also fixed and this is also fixed. And this lies in between this. So therefore, there exists theta I and theta I dash with minus 1 less than equal to theta. Both lie in between minus 1 to 1. Such that Axi minus 1 to Xi Fx dx is nothing but Fxi plus theta I delta Fi. Okay. And Xi minus 1 to Xi integral Gx dx is equal to Gxi minus 1 plus theta I dash delta Gi. Let's say this combined equation 2. So this is equation number 2. Okay. Okay. So from 1 and 2, what we got? From 1 and 2, we get, what we get? We get Fx Gx A to B is equal to we put the value, you will get summation I goes to 1 to n. Okay. So Gxi, okay. and it is GXI, FXI, okay, plus summation, and this is delta Xi here. Delta Xi plus summation I goes to 1 to n, okay, Fxi minus 1 Gxi, okay, delta Xi plus sigma, okay. Let's say it equation number 3. What is where sigma is? Sigma is equal to sigma is equal to sigma is equal to summation I goes to 1 to n, okay, Gxi delta Fi theta 1 theta I delta Xi plus, okay, plus summation I goes to 1 to n I goes to 1 to n F Xi minus 1, okay, delta Gi, okay, theta I dash delta X. Now, this sigma can also be written. So, this implies, how can sigma be written? Okay, so this is sigma. Okay, so from here, so let's say sigma. So let's say this sigma is equal to equation number 4. Okay, so this, let's say it is 4. Equation 4. Since, so by since F and G belongs to RAB, okay, we get capital F and capital G are continuous on closed interval AB. Okay. Continuous functions are bounded. Continuous F and G are continuous on AB. This implies continuous function on a closed and bounded interval are always bounded. So this implies capital F and G are bounded on closed interval AB. This implies there exists k greater than 0 such that capital Fx is less than equal to k and capital Gx less than equal to k for all x belongs to AB. Now from equation 4, we have sigma is less equal to summation I goes to 1 to n gxi theta I delta fi theta I delta xi plus summation I goes to 1 to n f xi minus 1 delta gi theta I dash delta xi. Then this will become less than equal to summation I goes to 1 to n. Okay. Gxi, but this is non-negative, so it will remain as it is. Okay. So theta I and delta xi will remain as it is because this is non-negative. Summation I goes to 1 to n f xi minus 1. So delta g will remain as it is, and this is the theta I dash, and this will be delta xi. It will remain as it is. Okay. Delta x. So this gx is less than equal to k, fx is also less than equal to k, and theta I lie is between minus 1 to 1. So their absolute value will be less than equal to 1. Okay. So this is less than equal to I goes to 1 to n. This is k. This is delta fi. This is 1. Theta is less than equal to 1. Absolute value. Delta xi plus summation I goes to 1 to n. Similarly, it is less than equal to k delta gi 1 delta xi. So this is equal to k is outside. This is equal to I goes to 1 to n. This is delta fi delta xi plus summation I goes to 1 to n delta gi delta x. What is this? What is this? This is, you put the value of summation I goes to 1 to n capital Mi unless small mi delta xi plus summation I goes to 1 to n delta gi. So this is mi dash small mi dash delta xi. Okay. Now what is this? If you will expand this, what you will get? So expand this. Summation I goes to 1 to n mi delta xi minus summation I goes to 1 to n mi delta xi. Okay. This is 1 plus this is summation I goes to 1 to n mi dash delta xi minus summation I goes to 1 to n mi dash delta xi. So what is this? This is nothing but UPF. UPF on close interval. Sorry, this is UPF. This is minus LPF. And this is the UPG minus LPG. So this implies no absolute value of sigma is less than UPF minus LPF. Okay. UPG minus LPG. So letting non-P tending to 0, we get what we get when non tending to 0, this whole part will tends to 0, this will part tends to 0. Okay. So we get, so when non tending to 0, this part, because f is Riemann integrable, so this part will tends to 0. Okay. This part tends to 0, this part tends to 0. So we get that this tends to 0 because UPF minus LPF tends to 0 and UPG minus LPG tends to 0 as non-P tending to 0. So this implies non. So finally, what does it mean? It means sigma tends to 0. If absolute value of this tends to 0, it can only sigma tends to 0. Because absolute value is tending to 0, obviously sigma is tending to 0. So this implies sigma tends to 0 as non-P tends to 0. Okay. Okay. Now again, what is equation number 2? Now from equation 3, we have fx gx a to b. This is summation I goes to 1 to n gx and what was this? This was f xi delta xi plus summation I goes to 1 to n f xi minus 1. Okay. Let me check again what was in equation number 3. And gxi delta xi. Let me check again. So this is this. So this is nothing but actually so this will be gxi minus 1. Sorry. So gx minus 1. Okay. So what is this then? So this is gx minus 1 delta xi plus sigma. Okay. So letting non-P tending to 0. we get. So norm tending to P0, this is Riemann sum of Gx, Fx, Riemann sum. Okay, this is Riemann sum of this function, Gx, G into Fx, G into F. And this is Riemann sum of, this is Riemann sum of F, capital F into G, small g. Okay. Now, so I would like to write one line. Okay. Because F and G are continuous function, capital F and G are continuous function, and small f and small g are Riemann integrable function. Continuous functions are Riemann integrable. So we get their product is Riemann integrable since F, G are Riemann integrable, and also capital F and capital G are Riemann integrable because capital F and G are continuous on AB, and continuous functions are Riemann integrable. Okay, we get G into F, G F small f and F small g also Riemann integrable over closed interval AB. Okay. Okay. So I want to give one name to this equation. Let's say which equation it will be. Let's say this equation 5. Okay. Let's say this equation 5. This equation. So this is Riemann sum of G, capital G into F function, and this is Riemann sum of the Riemann integral function capital F into small g. So when norm tending to 0, this will be integral, corresponding integral, Riemann integral. So letting norm P tending to 0 in 5, we get what is this? This will be fixed A to B, but the first summation will become integral A to B G x f small f dx, and second integral will become A to B capital F x small dx. And because this is tending to 0, this will become 0 because sigma tending to 0 as non P tending to 0. So sigma is tending to 0. Okay, sigma is tending to 0, so this will become 0. Okay, so that is why in place of sigma I can write 0. Okay, so sigma tending to 0. So this implies what we have. So this implies integral A to B capital Fx small gx dx is equal to Fx gx A to B integral minus A to B capital Gx small fx so this is fx dx. Okay, so this is proved now. This formula is proved. So this is integration by parts formula. And integration by parts formula is proved. Okay. So if you have any problem related to this lecture, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's session. We will see you in next session.